right, let's look at another example. This time we're going to look at velocity. Suppose we want to calculate the average velocity for the first 12 seconds. To find the average velocity, I need to know my displacement, and I need to know the time. All right, how am I going to find my displacement? Well, I look at where I ended up minus where I started. So where did I end up at 12 seconds? At 12 seconds, my position is 0 meters. When I first began, my position was 10 meters. So my displacement is negative 10 meters. All right, now remember from previous units, negative 10 meters means on the graph, from where I started to where I ended, I went down 10 meters. Well, I started up here, I ended down here. This, my ending point, is 10 meters below my starting point. So I do have negative 10 meters of displacement. My time is still 12 seconds. So my average velocity is going to be negative 10 meters. Put that on the next page. Negative 10 meters divided by 12 seconds. All right, and I need a calculator to find that number. I think it's about 0.84, but let's check. And it's actually negative 0.83 meters per second. So my average velocity for 12 seconds on this graph is negative 0.83 meters per second. This is what we mean by average. It doesn't have anything to do with where the lines went. It's where I started and where I ended. So far, so good. Let's try one more. This time, I'm just going to sketch a graph. Oops. All right, so here's the position axis. Here's the time axis. We'll label those real fast. And time. All right, and let's suppose this graph's nice and simple. It's just a line that looks like this. All right. Now let's see what's really going on here. Let's say I'm going to start at 0. Both axes are going to start at 0. So this is 0 seconds. This is 0 meters. And sometime later, I need to draw some lines here. Sometime later, I'm going to call this time t. I have reached a new position. My new position is over here. And we're going to call my new position x, because x is the variable we use for position. So in time t, I traveled to position x. Now because this is a line here, this is a straight line that doesn't turn around and come back, my distance and my displacement are both the same. I went from here to there. Oh, wait a minute. I better have a name for this place down here. Okay, so here's what we do. This is a position also, but it's a special position, so we're going to give it a special label. This position is also x, but it's my starting x, or my original x. So I'm going to use a little subscript here, which is an O. Okay, so XO, X original, X initial, is where I started. X without anything else is my ending point. That can be anywhere on the line, and t is the amount of time it took. Okay? Now, let's look at this graph a little more carefully. In order to calculate speed or velocity, remember, again, we haven't turned, so speed and velocity here are the same. I need my distance divided by my time, all right? We've used some symbols to do this, so let me do this real quick. Here come the symbols. Delta x divided by delta t. So that's how I calculate speed. Now let's look at the graph a little more carefully. What is delta x? Well, here it is right here. We'll use blue for this one. Delta x represents this length in blue. That's not the greatest line in the world, but that's delta x. What is delta t? Well, delta t represents from start to end. The red line is delta t. Okay, maybe we're not used to seeing this way. Let me think about delta x again. Delta x could also be this over here, right? Now, think back to your algebra days. Let me get rid of this because this is a little confusing. In algebra, delta x represents what on this graph? Excellent. Delta x is the rise of the graph. What about delta t? Okay, think. Delta t is the run of the graph. What do I get when I divide rise by run? All right, so let's look at this for a second. Speed equals rise divided by run. That looks awfully familiar to me. You know, I think there's probably a name for rise divided by run. You think back to what you've known from math, rise divided by run is nothing more than the slope of the graph. So when we define speed as distance over time, or velocity as displacement over time, what we're really talking about is slopes on graphs. And so another way to define these quantities is to say they're the slope of a position versus time graph. Now if you go back and think about what we did on these previous questions, there's no line connecting 10 meters and 0 meters. But if we were to draw that line in, let me draw it real quick. We'll use this to draw it. If I were to draw the line from 10 to 12, it would have a negative slope. The rise would be down 10 meters. The run would be over 12 seconds. And this number that I got for my answer over here would represent the slope of this line that I drew on the graph. All right, let's go back one more. In this problem, we asked about distance. Well, drawing a line for distance here isn't really going to work on this graph. I pretty much just have to calculate it that way. And the reason that I can't draw a line on the graph for distance is because the graph turned. Okay? But just keep in mind, when we talk about velocities and speeds, we're really talking about slopes on graphs. That, in a nutshell, is what speed and velocity are all about.